Assalamualaikum, and I hope you guys doing well. Okay, so I want to make sure that you guys stay safe. I know that you guys can't wait to return back to our beloved university. Make sure that you guys practice social distancing and make sure that you guys stay healthy. Okay, for today, we're going to continue where we left previously, and I'm going to introduce you guys to different type of data summarization. Okay, I have in the previous video, I have introduced you guys to the different type of data analysis. All right, there is inferential, there is the descriptive, and there is the explorative data analysis. And then after that, I have introduced you guys, we have discussed in detail into different type of data. Okay, and the keyword here is the different type of data. We have two types. We have the categorical data or the qualitative data. And another type of data that we tend to collect is the quantitative data. We also have discussed the dimensionality of your data set. And that are the univariate, bivariate, and the multivariate. By all means, it depends on how many variables that you measured. One variable is considered as a univariate, two variables, the data you collected, is bivariate, anything more than two variables condition come the multivariate. And I also mentioned the importance of knowing the type of data and the dimensionality is to make sure that you choose the right summary for your data. And that's what we're going to discuss today. Okay, data summarization. I'm going to introduce you guys to the numerical summaries. There are two types of data summarization. You could do in a form of numerical summary, or you guys could do the graphical summaries. I think you guys pretty much know what the graphical summary is. For example, using the bar chart, using anything using certain type of graph. Those are considered as a graphical summaries. And then for this particular, we're going to discuss the numerical summary. For the numerical summarization, there are three types of ways you could summarize your data. You collected, for example, a univariate data. Okay, you have a list. There are two things. You guys, I'm quite sure once I mention the name of that particular summary, you pretty much, it actually belongs to this particular categories. Okay, there are three types. We have the central tendency measures. We have the variability measures, where you guys measure the variations. And then we have the relative standing measures. I'm not this naming, this nomenclature, this name is quite strange for you guys, but once I explain what kind of analysis belong to which category. For the central tendency measures, okay, remember that when you collect your data, okay, from the population, you do the experiment or you take the surveys and you record them. And then you have in the table that you record in your spreadsheet, whether using a Google spreadsheet or Excel, and then you calculate the mean, the median, the mode, where you guys looking at the center value of your data. Okay, these are the mode, the mean, the median are considered as a central tendency measure. In this instance, as I mentioned, you have your data distribution, and then you measure the center value, the mean, the median, or the mode belongs to the central tendency measure. So it's by measuring the average, the purata in Malay, okay, of your data. Okay, and in summary is you sum the values that you collected and then divide by the numbers of the sample that you have. For example, you record the values, you record the height of 10 individuals. You sum all of them, the height of them, and then divide it by the number by 10 individual. Okay, those are considered as the average. There are many more different kind of mean, but these are the most common that you guys are going to come across. Okay, there's a geometric mean, and we have the median. The median is, as you guys are aware, is looking at this exact middle values. Okay, and for the numbers, for example, if you have 5 individuals, you measure the height of 5 individuals. You take the person or the third, you arrange them from bottom to high, from the lowest value to the highest value, and then you measure the center. You just pick the third person, okay, the one that you measured, the third highest. The third highest is considered as the median. Okay. While for example, if you have the even number individual, for example, you measure 10 individuals, the height of the 10 individuals. Now you have the 4, 5, and 6. So you need to sum them together and then divide it by 2. Okay, the values that you get, okay, the values that you get by divided by the height from the 5th and the 6th person, okay, the 6th tallest person, those are considered as the median, okay, for the even numbers. Remember, these are the symbol. Once in a while, I think you guys come across the symbol with the X with the curly top here. So these are considered as these are the symbol, the standard symbol for the median. While for the mean, we have the horizontal line X and we have the mu symbol. Okay, these are the standard symbol for the mean. All right. Now we have the mode. The mode is the most frequent values occurs in your data. Okay. For example, like you measure the frequencies. Okay, you mentioned that 1, 2, 3, 3, 3, 4, 5, 6, 6, and then you, of course, the 3, 3 is the most occurrence. Then the 3 is considered as your mode. Depend. Why do we have 3 different type of central tendency measures? We are going to give you guys the best example which one you need to use. We have different condition. Sometimes best to represent your graph using mean. Sometimes it's best to represent your data using median and even using mode. For example, in this instance, we do the 5 observation and these are the values. And you guys notice that the 5 measurement here are equally distributed between each others. Okay. In this instance, when you calculate the mean and the median, it's going to be the same. In this instance, the mean is going to be 4 and then the median as well going to be 4. Another, for this particular reason, the best way to represent your data is just based by using mean. Okay. While if you guys notice in this situation, we don't have the mode because in this instance, there is only occurred one at a time. Okay. All of them occurred once at a time. And then we have another example. In this instance, you do 5 measurements. Somehow there is one that quite far away from your measurement. For example, this is either 11. If you put here in terms of centimeters, the diameter of a circumference of your whatever of the sand, for example, the sand particle, for example, these are. You guys notice there are one odd numbers here. Okay, somehow you guys notice if you calculate the mean and the median, you guys notice that the median and the mean or the average is no longer equal or no longer the same. In this instance, you guys notice that the mean, since we have this in the measurement, is quite far off from your 4 measurement here. Okay, now you guys notice that we have the mean become 5 while the median is still at the center of 4. Okay, so which one is the best to use? Of course, you have somehow this very odd data and this very odd measurement. This measurement we call as the outliers. Okay, every time when I mention outliers, I meant this kind of data that are distant themselves from the observation, from the other measurement. Okay, so in this instance, when you have a data that skewed or the outliers, then the best way to use is to use median instead of the mean. All right. Again, in this instance, we don't have the mode because it's only occurred once. 1, 2. There is only occurred one measurement at 2. We measure there is one frequency. There's only one frequency at 3, 4, and 5, and 11. Okay. Another situation is, in this instance, you do the measurement 5 times, and then you found that your third measurement you have the measurement at 3 have occurred twice. Okay, in this instance, we have the mode. Mode is equal to 3. And then we will calculate the mean here, the mean and the mean, and now we can calculate the median, and then we calculate the mode. Somehow the mean in this instance is equal to 3.4. Well, for the median, since we have this kind of distribution, the centered tendency is going to be more accurately represented by the median and the mode, which is in this instance, we have the value at 3. So in this instance, the best way when you're dealing with this kind of data, or any data that were arranged in order, or any data that being arranged in categorical, then the best way to use is to use the median or mode. Okay, so that's why every time when you do the analysis, make sure you not just calculate the mean. You need to also assess the median and the mode. If the mode is not always occurs, but there are other points. If somehow you come across any categorical data where you could calculate the frequency, where you record more than once, then you need to measure the mode as well. Okay, so remember, measure 3 components for the central tendency measure: the mean, the median, and the mode. Okay, these are important because when we want to represent our data, we want to make sure we have to have at least 2 central tendency measures that can represent your data accurately. In this instance, have I mentioned here before, if your data evenly distributed, then we can just use the median or the average. While for the data that have a skew or outliers, the best way to represent your data is by using the median. Okay, because the outliers that we have here could be due to many reasons, due to the technical errors. All right. And if you measure more data and then these outliers become more prominent, so the best way to represent your data is using the median. Okay. And then if we have data that being recorded into a categories or arranged in order, or where which you guys measure the frequencies, the best way to calculate your central tendency, the center of your data, is by using the median or the mode in this instance. And then when we do the measurement, we not just calculate the center of your data the center of your data distribution. We also looking at the variation of your data. Okay, so by all means, we calculating the width, the spread, how spread your data is away from your center value. Okay, you calculate the mean, you calculate the median. You want to know how far your data from the center, from the center. For example, you have this time point, you have this point, this data point here. How far is it from the mean, from your mean? So the calculation that fall under the variability measures is the variance and standard deviation. Okay, not standard error mean. Standard error mean is not the numerical summarization. And then another one I'm going to introduce you guys today is the interquartile range. So remember, you have the centered value. You want to calculate the width of your data. So why do we need to calculate? Why do we need to know the variation of our data? If we took a sample from 2 different populations in this instance, okay, you record them and then you calculate the standard deviation. Okay, you plot them, and you guys notice there are certain occasions where you guys going to have the same mean, but somehow this data distribution is going to be different. Okay, for example, in this instance, the A have much more narrower distribution compared to the sample taken from the population B, which is much more wider. So that's why we need to have every time we summarize our data, we need to consider the variation as well. So you have the same mean, however, standard deviation of your data is not the same. Okay, the variance. So what is meant by the variance? Variance is actually a square of different value from the means. Okay, now you have the mean, and then you have your different point here. So what happened here is you measure the difference between that point to your mean values, to your average. Okay, for example, you have this one, you calculate the distance. Of course, what happened here, when you have the data, you point here, and then you center here, what it meant is you're going to have a negative or positive values. Okay, so why do we need to square them every time? The whole reason why we square them, we want to remove and then negative. That's why we square the values. Why we calculate the variance is to know the distance of your data. Okay, now you have the centered value, you want to know the distance here. Okay, how much what are the distance from this point to your centered value, to the mean here? What are your the distance between here and here? Of course, when you have, for example, in this instance, when the mean is bigger, than your center point, when the mean is bigger than your data point is, then you guys going to have the positive and the negative values here. You square them to remove the negative, the negative values, so you can sum them up and then you calculate the average, okay, of the differences. That's the whole point of the variance. So now we have the standard deviation. Okay, the symbol here is the sigma. Okay, while the variance is the sigma squared. Well, for the standard deviation, the symbol is the sigma or SD. Okay, the reason is we call it standard deviation is we calculate standard, the typical differences between each data point and the mean. Okay, so what it meant is if the data point is close together, then the standard deviation is going to be smaller. So if you have your data small closer, then you guys going to have a small standard deviation. While if you have data point that away from each other, then your standard deviation is going to be bigger. And if you guys notice in terms of calculation, if you guys looking at the standard deviation, the symbol is sigma, but the variance is sigma squared. It's actually a square root of the sigma squared. See, standard deviation, the way we calculate the standard deviation is by square root the variance. All right. So these are the example. As I mentioned, if your data are very close to each other, okay, then your standard deviation going to be smaller. Okay, for example, in this instance, you have your data from 2 to 5. Okay, then you have this 3 here, spread out twice. You calculate the standard deviation. The centered value here is at 3.4. And then you calculate here the standard deviation is smaller compared to these two measurements. Okay, and then how the variance being affected by the outliers. If you have one outliers here, you guys notice that the standard deviation become bigger. Okay, you guys have to notice. If you forgot, this point is the outliers. Okay, outliers always affecting your centered values, but also going to affect your standard deviation. Okay, we have the interquartile range. Suppose the interquartile range, if you divide your data into 4 quarters, okay, and the interquartile range is the range is that fell under the middle half of your data. So you have your median, and then you measure, and then you divide it into you have your data into 4, and then you calculate the median falls between the Q2 and the Q3 of the quarters of the second quarters and the third quarters of your data. The quarters in this instance, we call it as a quartile. You have to arrange your data from the smallest to highest, from the smallest to the largest value. So the first value, the first quarter belongs to the smallest numbers, and then the second, the fourth quarters is the largest value in your data. For example, you divide your data from the Q1 into Q4, and then you have your median here. Your median, your interquartile range is fell onto your first quarter, and then you're on the third quarter. All right. So if we have a table, a list of your data, so in this instance, you divided them into 4. Okay, 4 data. In this instance, we have 1, 1, 3. You arrange them together, and then the 7 is your median, and then we have, since these data are equally distributed, so you guys going to have the median is 7, and you have the third quarters, the first quarters here. Okay, the first quarter usually, every time we point the quarters, we tend to say these are the first quarter at the point, at the edge where they fell here. So if you have a distribution, all right, of your data, and the center is your median, these are evenly distributed data. So the interquartile range tells the where your data lies, the shape of your distribution, somehow describe the pattern, the shape of your data distribution. Okay, you have the Q2 and the Q3 here. Okay, the median at the center of your data, and then the Q2 and the Q3 falls within the interquartile range. Okay. So now we have the relative standing measures. So relative standing measure is you want to know which quartile, where are they located in your data. That particular point or that particular values located at which quartile or which percentile. Okay, so the whole point, the whole motivation when you calculate the relative standing measure is to compute or to describe the relative position of specific measurement, specific data point in the data that you have collected. There are two ways in the system. We have the quartile and the percentile. So you want to point in your data points, for example, like the values, the measurement, where are they located in your data distribution. Okay, so for the quartile, I've been discussed before, where by all means you describe your data, you break your data into 4 quarters, okay, and then you have your medians. So when we mentioned about interquartile, we talk about the range of your data that located on that falls from the end of the Q1 until the end of your Q3. When we want to point which part, if for example there's certain particular data point that you are interested, you want to know are they fall into Q1 or Q2 or Q3, then we use the percentile. The percentile also called a quantile. You reorder your data from the smallest to high. You want to know at 86th percentile where your data falls at. What it meant, for example, I'll give you an example. If your data point stored at 86, what does it mean? 86th percentile, it indicates that the data point is 86% higher compared to the other data. The number 3 here is 25th percentile. Okay, not 25%. The 25th percentile, what it meant here is it's located at the first quarter of your quartile. For the 76th percentile, but by all means, the 70th belong to the number 10 here, which falls the group under the fourth quartile in your data. So when we use the term percentile, we use the term the 9th, the 1st, the 2nd, the 3rd, up until 100. Okay, indicate the value falls or below in a given n percentage. Okay, so we mentioned at the 75th percentile, what it meant is indicate the data point is 75% higher compared to the other data. All right. So another example is the Q1 indicate equal to the 25th percentile of the data. So percentile. So what it meant here is if you want to find your data point, for example, at this particular point, it will give that the n percentile, the value of your n percentile here. So what it meant here, this n percentile values here is much higher compared to this particular data. The question, for example, like you want to know data that falls below certain percentile, for example, at 25th percentile. You want to know how many data, so then you know you are recording the data that has been collected up until this region. If you change here into 25, change it into 25 percentile, how many data falls within this region? Okay, the median is your 5th percentile, the 50th percentile. In summary, In analyzing your numerical data, we always present our data using a numerical summary. And usually we combine two categories for summarization. Either we choose to use central tendency. We always use the central tendency measures, and we combine with the variance. And sometimes we combine the central tendency with the relative standing measures. We tend to use either the two combination. Okay, but the central tendency is a must. Or we pair it with the relative measures. And this is very important, especially when we're dealing with a very, very large data. I think, for example, if you're doing with the transcriptomic data or any form of data these days, all right, you tend to deal with a very, very large data. So you need to use some form of mechanism to summarize to make sure that the readers are going to understand. The only way for you to make sure that the readers understand your data, you need to summarize them in a form of the one that I taught you guys just now. So categorized into three groups: the central tendency, the variation, and the relative measure. So every time when you deal with the large data, these are the things that we always use to present to the readers. We provide the raw data, but to make sure that the others understand our conclusions or our finding, we have to summarize the raw data that we collect. Thank you.